Hello everyone, welcome to Chemistry EduHub channel. Today we are going to talk about the third part of the chapter, that is quantum numbers. So quantum numbers are those which are given as small integers which completely defines completely of an electron in an atom. So just like we have fingerprints, just like there is a particular signature for any bank, the same way for any electron present in an atom, there has to be a set of quantum numbers which define its position completely. Such numbers are called quantum numbers. So there are 4 set of quantum numbers for every electron in a given atom. The first is principal quantum number denoted by N. Second is azimuthal quantum number denoted by L. Third is magnetic quantum number denoted by M. And fourth is spin quantum number denoted by small s. The first and foremost important one is the principal quantum number denoted by the symbol small n. This is proposed by the scientist Niels Bohr. So Niels Bohr proposed the principal quantum number for the electrons in any atom. It is denoted by the symbol small n. N can take up the values starting with 1, 2, 3, 4, so on up to infinity. So the orbits or the shells, principal quantum number mainly talks about the shell or the orbit. Discusses about shell or orbit. So if we say n value, n indicates the stationary shell or the orbit of an electron. So if the n value is 1, that means they can also be designated as K, L, M, N, O and so on. These are the other representation for the n values. So if n is equal to 1, it means it is the first orbit, or you can say K shell. If n is equal to 2, then that means it is the second orbit. It can also be represented as L. The same way n equal to 3 is third orbit, M. N equal to 4 is fourth orbit, N, and so on, so forth. Okay, what is the importance of this principal quantum number? Why do we need it? It mainly talks about the energy and size of an atom. The energy and size of the orbit in an atom. Orbit in an atom. So as the n value increases, the energy and size also increases. So we can say n, energy and size also increases. So we can say n is directly proportional to energy and size of an orbit. So to find the maximum number of electrons present in an orbit or shell is nothing but 2n square. Suppose if n is equal to 1, then 2 into 1 square equal to 2. So in the first shell, only 2 electrons can be accommodated. If n is equal to 2, then 2 into 2 square, then it is 8. Like this, according to the n value, you can have 2, 8, 18, 32, then 50 and so on like this. As the shell number increases, the size and the energy increases, and the number of electrons that can be accommodated also will be increasing. The second quantum number is the azimuthal quantum number, which is also called as, the other names for the azimuthal quantum number is angular momentum quantum number, or orbital quantum number, or subsidiary quantum number. These are the other names for azimuthal quantum number. It is denoted by the symbol small l, and this was proposed by the scientist Sommerfeld. Sommerfeld is the scientist who proposed this quantum number. Now, L indicates, what is the importance of L? L indicates the presence of subshells in an orbit or shell. So, inside the shell, you find subshells, that is discussed by the azimuthal quantum number. Now, apart from that, L also denotes the shape of the subshell or orbital. L also defines the shape of the orbital, and L value depends on n value. Since n value starts from 1, 2, 3, 4, so on, L starts from 0 to n minus 1. Since L ranges from 0 to n minus 1, we need to write the L values according to the n values only. So we know that n starts with 1, so L has to be what? 1 minus 1, which is equal to 0. So this indicates an s orbital whose shape is spherical. Similarly, if n is equal to 2, L has to be 2 minus 1 is 1, which indicates p orbital or p subshell whose shape is dumbbell. Similarly, n equal to 3 is L equal to 3 minus 1, 2, then it is d subshell whose shape is double dumbbell. And if n equal to 4, L has to be 4 minus 1, which is 3. We consider F subshell and the shape is four-fold dumbbell shape, or you can say it is complex shape, or you can say flower-like shape. So these are the various values possible for L values, which depends on the n value. The third quantum number is the magnetic quantum number proposed by the scientist Landé, and it is denoted by the symbol M. M values depend on L values. So based on the L value itself, we write the M value. So how do we write it? M values range from minus L to plus L. And how many number of M values can be possible for a given subshell can be given by the formula 2L plus 1. So this magnetic quantum number mainly discusses about the spatial orientation, which means in a given subshell, that is S, P, D and F, how the electrons are oriented, whether they are oriented in the x-axis or along the y-axis or along the z-axis. Based on the number of orientations, we get the M values accordingly. Suppose if the L value is 0, then M value is also 0, because the M values range from minus L to plus L, including 0. So M has to be 0. This means S subshell has only one orbital, that is spherical S orbital. If L value is 1, that means M has to be minus 1 to plus 1. This includes what? Minus 1, 0, plus 1. How many values are there? Altogether 3 values are there. So for P subshell, you will have Px, Py and Pz. Similarly, if the L value is 2, then M ranges from minus 2, minus 1, 0, plus 1, plus 2. So how many values? 5 values are there. For the D subshell, the orientations are dxy, dyz and dzx, and dx square minus y square and dz square. So there are 5 orientations possible. Similarly, L equal to 3 is M minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Altogether 5 are possible. 7 are possible. So for F subshell, there are 7 orbitals available. The fourth quantum number is the spin quantum number, denoted by the symbol small s, which was proposed by Goudsmit and Uhlenbeck scientists. This explains the spin of the electron. So, around the nucleus, the electron is observed to revolve around the nucleus. Along with the revolution, it also rotates around itself just like the earth does around the sun. So, while the rotation of electron there creates a spin, because electron is a charged particle. So, because of the rotation, a spin is generated. Now, this spin can be either in the clockwise direction or in the anti-clockwise direction. This is clockwise or anti-clockwise. So, the electron can rotate either in clockwise or anti-clockwise. Now, because of the clockwise direction rotation, the spin generated is plus half. For the anti-clockwise, the spin generated is minus half. So, whenever the electrons are represented in an orbital, we can either write in the upward direction or in the downward direction. But when two electrons are there, obviously one has to be upward, one has to be downward. So, this indicates clockwise plus half spin. This indicates minus half anti-clockwise spin. But if there is only one electron, the electron can rotate in the upward or in the downward direction. This video is about the 4 quantum numbers, and let us see the important questions now. So mostly from this concept you can get 5-mark questions like what are quantum numbers, discuss their importance, briefly explain quantum numbers and its types, write a short note on principal quantum number or spin quantum number, principal quantum number or azimuthal quantum number. Like this they can ask for 5 marks. Or if they ask for 3 marks, they can just ask you what is principal quantum number, write its importance, or they can just ask you any one type of quantum number. So either 5 marks or 3 marks can be expected, and sometimes they can give you a problem like calculate the quantum numbers for 5th electron in oxygen atom. Such examples also can be asked. In such case, what you need to do, write the oxidation electronic configuration of oxygen, that is 1s2, 2s2, 2p, 4. 2, 4. 4 electrons are done. Now what about the 5th electron? This is the 5th electron. So 2p orbital. So the quantum numbers will be what? Second shell. Then L value for p subshell is 1. Then M values can be minus 1 to plus 1. And spin can be plus or minus half. This way you need to write the 4 set of quantum numbers for any element if they ask you. So these are the possible questions, and this is about the quantum numbers. Thank you.